In this video, we're going to take the first derivative of our function using the quotient rule. To use the quotient rule, we'll let our numerator be represented by u and our denominator represented by v. The quotient rule tells us to take v times the derivative of u minus u times the derivative of v, all divided by v squared. In other words, with our example, we will have x cubed times 10x to the fourth, and we get this by using the power rule, bringing the 5 out front, multiplying with the coefficient 2, and then taking our exponent 5 and subtracting 1. Back to our formula here, minus, and then u, which is 2x to the fifth plus 8, times the derivative of v, where v equals x cubed. So that gives us 3x squared as our derivative, all divided by by x cubed squared. Okay, so we've plugged in our values of u and v and their respective derivatives into the quotient rule formula. Now, let's simplify. So we have x cubed times 10x to the fourth. That gives us 10x to the seventh minus, and then we'll distribute our 3x squared across our binomial, 2x to the fifth plus 8. So we have 3x squared times 2x to the fifth. That gives us 6x to the seventh plus, and then 3x squared times 8 is 24x squared, all divided by x to the sixth. Next, I'd like to simplify, and there are different ways that different calculus books will simplify these product and quotient rule problems, or really any problem where you're taking a derivative. You will see some variation. What I'd like to do here is to break up our current rational expression, a rational expression being the ratio of two variable containing functions, and I'm going to break them apart as follows. 10x to the seventh minus 6x to the seventh gives us 4x to the seventh. So I'm going to write 4x to the seventh divided by x to the sixth minus 24x squared over x to the sixth. From here, I'm able to cancel out x to the sixth, And I'm also able to cancel out x squared. This leaves us with our final result, f prime of x equals 4x minus 24 divided by x to the fourth. And so here we have the first derivative of our function, which we obtained using the quotient rule. That concludes our example. I hope you found it helpful, and we'll see you next time.